Hello everyone, welcome to Watched Industry Express channel, produced by Made-in-China.com. Today, let's talk about distributed photovoltaic power stations today. Let's get started with a brief introduction of distributed photovoltaic power stations. For the first part, let's get to know the concept of photovoltaic and how it generates electricity. As we all know, photovoltaics, short for photovoltaic power system, is a type of power system that utilizes the photovoltaic effect of semiconductor materials in solar cells to directly convert solar radiation into electrical energy, representing a novel approach to electricity generation. Let's take a look at what solar power stations are all about and the different types they come in. Photovoltaic power generation can be classified into centralized photovoltaic power generation, distributed photovoltaic power generation, storage-capable photovoltaic power generation, and non-storage photovoltaic power generation. Let's dive a bit more into what distributed solar photovoltaic generation is all about. Specifically, it's a system using photovoltaic modules to directly convert solar energy into electricity. It advocates for local power generation and consumption. It efficiently supplies green energy, yielding long-term economic benefits from power generation for its users. Components of distributed photovoltaics. Schematic of a distributed system. The system consists of the photovoltaic DC segment, the inverter section, and the metering component, among others. For the second part, let's chat about what kind of research you need to do upfront if you're looking to set up a distributed photovoltaic project. Preliminary research for distributed projects. Research 1. Owner's investment willingness. Research 2. Availability of installation area without significant shading obstructions like buildings. Research 3. Ability to meet the load-bearing requirements for the modules. Cement roofs should support around 35 kg per square meter, while color steel tile roofs need to support more than 15 kg per square meter. Research 4. Electricity pricing, consumption levels, usage periods, and desired self-consumption ratio. Research 5. Conditions of the local electricity grid, such as the capacity of the on-site transformer and grid connection point. Research 6. Construction conditions, urban versus rural, presence of polluting enterprises, and transportation facilities. Design and construction of distributed PV projects. Parameters for a 1 MW distributed system. Installation method, rooftop, ground, modular arrangement, vertical, horizontal. Land occupation, 8,000 to 15,000 square meter. Wind load, 0.5 kN per square meter. Snow load, 0.3 kN per square meter. Equipment installation weight, 25 to 30 kg per square meter. Operating temperature, -45 degrees to 85 degrees. Grid connection point rated frequency, 50 Hz. Design and installation of distributed PV generation. Explained with a 1 kW example. First, material packaging. Second, mounting system installation. Third, module installation. Fourth, accessories installation. Fifth, aesthetic appearance. Sixth, schematic diagram. In part 3, let's explore how we can broadly promote distributed solar PV systems. Advantages of distributed photovoltaic power systems. First, investment with long-term returns, using idle rooftops, enhancing energy quality without land use. Second, eco-friendly, silent, and clean energy generation. Third, aesthetic design integration with buildings. Fourth, minimal maintenance, mostly sample cleaning. Fifth, insulates roofs, reducing heat in winter, cooling in summer, and dampening rain noise. Sixth, saves electricity for households. Offers public buildings a way to showcase environmental commitment. Adds to green building credentials and reduces energy costs for large facilities. Enables participation in carbon trading on low-cost entrepreneurial ventures. Classification and development of distributed PV customers. First, home and small PV systems are primarily self-funded by owners and installed on rooftops. Second, commercial users with high consumption and electricity costs enjoy high returns and quick payback, but are limited by rooftop space. Third, industrial users have substantial consumption and moderate electricity costs, offering good returns but often face financial constraints, making them key PV market targets. Fourth, government and public entities are willing to invest in PV for subsidies despite low electricity prices. Fifth, residential users are cost-sensitive, and small-scale systems have slow payback, hindering widespread adoption. Sixth, large commercial PV projects rely on rooftop leasing and third-party investment. Lastly, let's take a look at how distributed solar PV is applied in some real-world examples. Integrating photovoltaics with agricultural greenhouses. Inverter, combiner box, mushroom greenhouse, mushroom, industrial rooftop power stations. A 20 megawatt PV station case study. The annual power generation is about 24 million kilowatt hours. Approximately 9,610 tons of standard coal are saved each year. About 18,000 tons of carbon dioxide emissions are reduced annually. Rooftop distributed photovoltaic case examples. Thank you for watching.